Hello, this is my presentation on computational thinking and how we can implement it at Roncalli Catholic High School. So, first off, what is computational thinking? Computational thinking is a way of problem solving. It is a method involving 4 pillars, including decomposition, pattern recognition, abstraction, and algorithmic design. I encourage you, when you have some free time, to watch the current video on screen. However, I will go ahead and play a small snippet of it for you now, but in your own time, please go back and watch it fully.
What is computational thinking?
Maybe thinking like a scientist, or more like a computer scientist?
Taking a complex idea and simplifying it into simple few concepts.
I guess it's being really good on a computer.
I actually really don't know what you mean by computational thinking.
So it's a bit confusing. Is it problem solving? Is it programming? We want to introduce computational thinking to all educators. So whether you teach math, science, computing, or the humanities, computational thinking can really enrich your subject, your teaching, and your students' exploration. So we'll show you how computational thinking in your classroom can enhance your curriculum. It doesn't replace what you already do, and it doesn't require any additional knowledge of programming or other technology.
So now that we've watched a small snippet of that video, let's go ahead and continue on. I encourage you to watch the rest of it in your own time. So how can I implement computational thinking into my classroom? As outlined in the video, you can implement computational thinking into any classroom, whether that be music, math, social studies, physics, environmental science, and media literacy. You can literally incorporate computational thinking into anything, and I encourage you to take some time and go back to this slide and read a few of the ways that other people are implementing computational thinking into their classrooms. For instance, in math, they're using it to interpret and visualize statistics and athletes' performance. One that I find most fascinating is music. They use algorithms to study intervals, rhythm, and composition. So the rest of this presentation is going to outline some lessons that you can utilize in your specific subject area to enhance your classroom. And I encourage you to pick 1 or 2 of these lessons off of your slide and use them in your classroom. I've picked these from databases and have selected ones that I feel would be most beneficial to your classroom. So for algebra, there is a football lesson, and it's students are picking football players and using statistics and presenting them as ratios to select players for their draft. And they're having to use computational reasoning and data sorting in order to do that. In geometry, there is the superhero transformations projects. Students design their own superhero and are able to distill its own core of geometry shape. And it is a story system, so you are able to incorporate some English in with this activity as well very easily, and this could be an activity that you maybe incorporate with the English teacher and do in both of your classrooms. And as always, on the slides, these lessons are linked so you are able to click on them and further investigate what's needed for the lesson and any prep involved. For science, I have an earth science lesson, which is the students will be able to familiarize themselves with data representation and create a visualization of numeric data. Also, students can use their findings to motivate and conduct more research on global energy. So the students are able to use what they find out about global energy in order to see the consumption across the United States and do some data sorting with that. And in science, similarly to the last activity, students go through a demonstration and they're able to, similar to a web quest, work their way through and figure out the difference between mRDNA and DNA. And this demonstration allows students to create a computer model and use a sample model in order to understand the differences between mRDNA and DNA. And then lastly, the one I found most interesting was the baby maker activity. And students are using their own genetic traits and answering a series of questions to create a model of their face. And if students don't do this correctly, they can leave off limbs. So this is a great activity that allows students to apply something they're learning in class about Punnett squares to their own lives. So the next activity is American history, and that is over the events that led to the Civil War. And basically, their students are trying to determine what they could have changed to change the outcome of the Civil War or to not have it happen. And they're trying to pick the key events that led to the Civil War, which many historians don't even agree on today. So this really brings it down to them on a level where they are able to create a flow chart and break down the process of what led to the Civil War. Civics, this activity is over voter rights and voter ID laws, and they're able to interview family members and collect data and sort through it, break it down into smaller parts to determine people's views about voter ID laws, and it utilizes information from a PBS lesson plan that is also linked. And again, both of these lessons are also linked on my slide. So now we have English. For English, you are able to create a Lord of the Flies map activity that encourages students to break down the book into smaller parts and create their own map that visually tells the story and gives the students flexibility to include what they think is most relevant and allows them to break the book up into smaller parts. And then last, we have the Paper Pencil Code program, which enables students to create an interactive chatbot that answers questions as if they were Lady Macbeth. So this allows students to not only reason what the important parts of the book and how this character would answer her questions, it also allows them to analyze and fill and change parts of a programming language. Next, we have art, and this is personally one of my favorites. It did take a lot more work, I have to say, to find specific lessons for art, but I encourage all art teachers to dig for those lessons, and I've selected 2 for you, and when we get to the resources page, I will also point out where I found those lessons and where you can find more. Algorithmic art. This is taking a computer-generated artwork and breaking it down into smaller parts and having students create a doodle that is described in the algorithms they've created. And then we have Puzzle Pixels, which is a way to create a digital version of an image, and it helps you come up with a representation for that mosaic using pixels, and it also gets into talking about how we use pixels today in computers and relates the concept of using pixels back to art. Next and lastly, we have music. This lesson, the first lesson plan, allows students to examine various aspects of music such as scales, melody, and rhythm. And it allows them to discover patterns and enables them to modify an algorithm to improve the quality of the music generated in the algorithm. So again, just like in English, it allows them to go in and modify code to create what they want to. Lastly, we have music, well, second to lastly, we have music notation, which students can compare pitch of the music notation and use cards to put the order of the pitch, put the music notes in order by pitch. And that is a CS Unplugged activity, so you don't need computers in your classroom or technology to do that. And then lastly, we have creating music through Scratch, which a lot of students already are doing. And this lesson breaks it down, and they are creating Beethoven's Ode to Joy using Scratch. All right, so some lessons you can use in any classroom. So if for some reason you don't see your class listed here, here are some lessons that you can modify and use in your classroom. And again, any of these lessons that I've talked about, if you think, oh, I can modify that and use it for PE, do it. A lot of these lessons can be modified and changed to fit different subject areas. So the first one is on data deduction. And in many circumstances where a set of rules is given, further information can often be deduced by the appropriate use of logical tools. In this lesson, students will learn how to apply logical reasoning to deduce information from rules in a game scenario. So students are able to create a game and deduce the rules from that game. And that can be done at any class. And the use of game-based learning makes it fun for students. And then direction algorithmic thinking. Students break problems down into parts and are given oral instructions to break that problem down, which again, this lesson is pretty specific, but it can be that idea can be modified and used in several different types of classrooms. And then student engagement strategies. I really liked this because it wasn't necessarily a lesson plan, but it was ideas for engaging your classroom in computational thinking and keeping students engaged. And they were 10 simple tips that I believe any teacher would benefit from. Lastly, we have resources for educators. So computational thinking lesson plan repository, that is on Google, and it is linked in the slide presentation. And this has by far the most robust, I would say, repository of lessons. And they keep on adding lessons that are being submitted, is my understanding. Lesson plans and activities for computing. So this particular site right here is near and dear to my heart because it is based in London, but also it had activities for all different kinds of subject areas that weren't necessarily covered in the more robust Google repository. So this was another great resource. And then computational thinking unplugged activities are great for when you want a computational thinking activity but don't necessarily have a computer. And then below that, code.org has curriculums for teachers to teach computational thinking in your computer science classroom, or even if you want to teach it in an English classroom, you're able to do it there as well. And then other computational training resources for teachers are right here, and this actually just has some basic simple things, as well as some other additional resources for activities that you can incorporate into your classroom. Finally, some of them were listed on my resources, but this is mainly where I pulled information for the slideshow presentation. So feel free to use any of these resources in addition to the ones listed in the resources for teachers. Thank you so much for listening to my presentation. Please feel free to email me with any questions. Thanks.